Welcome to Crazy Problems to Easy Solutions. This is Satya Priya, MPhil in Mathematics. Today's topic is relation in sets. Now we are going to see the relation definition. Let A and B be any two non-empty sets. A relation R from A to B is a subset of A cross B satisfying some specified conditions. If x belongs to capital A is related to y belongs to capital B through R, then we write it as x or y. That means x is related to y. X or y if and only if x comma y is belongs to capital R. So now we have take in two non-empty sets A and B. Then we have defined in the a relation R from A to B is a subset of A cross B. We know cross B is a Cartesian product, so that it's satisfying some conditions. For that, for X is belongs to we are capital A and Y we are taking to capital B. So we can write in the relation form x is related to y. That means x or y. If x or y means then the condition is x comma y is belongs to capital R. Or else x comma y is belongs to capital R means obviously x or y. That means x is related to y. Next, domain, codomain and range of relation. The domain of the relation x are equal to x belongs to capital A, that means x or y. For some y belongs to capital B. So in that domain means x we are taking in the elements of the set A, and then is related to x is related to y, the y is some element of B. Then the codomain of the relation R is B. The range of the relation R equal to, so y belongs to capital B, that's why x is related to y for some x is belongs to capital A. From these definitions, we know that domain of R is a subset of capital A and codomain of R equal to B, and the range of R is a subset of B. So we have proved that R is a subset of A and B. Null relation. Let us consider the following example. Suppose A equal to minus 3, minus 2, 1 and B equal to 1, 2, 3, 4. A relation from A to B is defined as A minus B equal to 8. That means that no pair of A comma B such that A minus B is equal to 0. Thus, the R contain no element and so R equal to F. So, the relations equal to function. A relation which contains no element is called the null relation. If n of A equal to P and n of B equal to Q, that means number of elements in the set A is defined as P and number of elements in the set B is defined as Q. Then the total number of relations that exist between A and B is 2 power P into Q. We have to write in the 2 power of P into Q. So now we have seen in the related some problems. Let A equal to 1, 2, 3, 7 and B equal to 3, 0, minus 1, 7. Which of the following are relation from A to B? So first one, R1 we have to take minus 1, 1. So that solutions minus 1, 1 is an element of R2, but in the Cartesian product we have 1, minus 1 only is there. So 1, minus 1 and minus 1, 1 is not equal to 0. So this is not a relation. then R3. So we have defined 2 comma minus 1, 7 comma 7, 1 comma 3. Solution: R3 is a subset of A and A cross B, hence it's a relation of A to B. So these are the elements of we have tried in the sets A and B, and we have defined in the R3 is a subset of the A cross B. So this is a relation of A to B. A relation R is given by the set x comma y divided by y equal to x plus 3 such that x is belongs to 0, 1, 2, 3, 4, 5. Determine its domain and range. We have to find now the domain and range. So is that given that y equal to x plus 3. So now y equal to x plus 3, the x value is given 0 to 5. First we have to apply in the 0. Then y equal to 0 plus 3, the answer is 3. Next y equal to x plus 3, we have to put in x equal to 1, then the answer is 4. Then next next value we have to put x equal to 2, then the answer y value is 5. Then y equal to x plus 3 means we have to, instead of x we have to apply for the 3, then the y value is 6. Then we have to apply for x equal to 4, the y value is 7, and x equal to 5 means the y value is 8. So now we have to write in the relation. If x value is 0 means the y value is 3. We have to write the ordered pair in 0 comma 3. Then the next x value is 1 means the y value is 4, then 1 comma 4, and 2 comma 5, 3 comma 6, 4 comma 7, and 5 comma 8. So this is a relation we have written. Then the domain of the relation. So domain of the relation, we know that which is the numbers are consist in the x coordinate, we have to write in the domain of R. So that in look at the x coordinate is a 0, 1, 2, 3, 4, 5. Next, range of x. Range of x is instead of that we have to write in the coordinate of in y values. Then 3 comma 4 comma 5 comma 6 comma 7 comma 8. This is the y value, domain and range of R. Next, let a equal to 1 comma 2 comma 3 comma 4 up to etc 45, and or be the relation defined as is square of. So the relation is defined, that is in this square of on A. So write R is a subset of A cross A. Also find the domain and range of R. So we have write in the first, the set is A. A is defined in 1, 2, 3 up to etc 45. Let A be a set which contains some elements of A. So we have to write in A 1, 2, 3, 4, 5, 6. Now we have to write the other sets of the elements from A. The sets in the sets denotes the square of the values of previous set. So is the square of the numbers we have write in the 1 to 45. 1 is a square value, and 2 and 4, 9, 16, 25, 36. 36 after we have write in the 49. 7 7 sir is a 49, but 49 is a within, it is not a set of value. So we have consider for 1 comma 4 comma 9 comma 16 comma 25 comma 36. If A cross A 1 comma 1 and 1 comma 4 1 comma 9 1 comma 16 1 comma 25 1 comma 36, then etc 2 comma 2 comma 1 2 comma 4 2 comma 9 up to etc we have writing the all the set, all the elements of the sets. Now domain we have written, we know the domain values, that is in the A set. A is a 1 comma 2 3 4 5 and 6. Next range value 1 comma 4 comma 9 comma 16 comma 25 and 36. So we have find the domain and range of the sets. So thank you for watching in Crazy Problems to Easy Solutions. Keep on watching. Bye.